Welcome to decision making class. Today I'm going to discuss about the decision tree. The topic covered in this opportunity is how we construct a decision tree based on the decision table or the payoff table, then how we make the decision using Bayes decision rule or expected value, or we call it as the expected monetary value. Let's see the example of the Kelly construction payoff table. So this is our payoff table or decision table, which come up with the alternative actions, the probability, and also the state of the nature. So this is what about the profit. How we construct the model of the decision tree. So we have a decision maker here. Decision maker is symbolized by the D. And then we have the course alternative of actions, C1 and C2. This is the possible courses of action, or we call it as the alternatives. And we have the events or state of natures. And for the events, they have the probability. And O1 is the possible outcome, or we call it as the consequences or the payoff. If we construct the decision tree from the payoff table, it's very easy. So because the structure of decision tree, it consists of the first what we call about the decision node. Decision node is the alternatives that available for decision maker to choose. And this situation is controllable by the decision maker. The symbol of the decision node is the square, and they have the alternatives of action. So this is what we call about the decision nodes. And event nodes, or we call it as the state of nature nodes. Events may have happen after every action made by the decision maker, and it is uncontrollable by the decision maker. For example, if today is rain or not rain, so it's not uncontrollable by the decision maker. Decision maker only has information about the probability of each event. There are no complete information, such as today it's rain 50% and not rain is 50%. The event nodes symbolized by the sickle, so they have the probabilities. So this is what we call about the event nodes or state of nature nodes. How we construct the decision tree from the payoff table or the decision table? Then the first is we figure out the alternative of action. We draw the decision nodes with the square, and then you come up with the three alternatives. Whether you want to build 50 units of house, 100 units of house, or build 150 units of house. So after you build unit of house, then what will be happen? So that we call it as the future events or state of natures. If the demand is low, then how much the probability? If the probability is medium, then how much is the probability? And then if the demand is high, then how much is the probability? So from this decision table, then we can construct like this. The probability for the low 50 unit is 0.2, medium is 0.5, and high is 0.3. Also, it's the same for all of the decision alternatives here. And also they have a payoff. If you want to build 50 units of house and the demand is low, then payoff you got is 400,000. You want to build 100 unit of house and the demand is medium, then you got 800,000. If you want to build 150 units with the demand high, 0.3 is 1,200,000. So this is about the decision tree. After we construct the decision tree, then we use the Bayes decision rule to calculate the expected value or the expected monetary value. From those decision tree, then we calculate the expected value that we already calculate using the decision table in the last session. The expected value if you want to build 50 units of house is probability is time to low, and then 0.5 times to payoff, and the demand is high is times to payoff. Then we got the expected value for building a house 50 unit is 400. How about the next expected value? So we put it here. Yeah. And then the next is build 100 unit of house. Then expected value is low times to probability of low times to 100, 0.5 times to 800, and 0.3 times to 800. So we got 660. After that, we calculate, then we put it in the even notes like this. Then the next is how to build the unit of house 150 unit. Expected value is calculated by multiplying the probability times to payoff. In this case, then we got 570. So we put it here. So after we calculate all of the expected value, then the next is we need to choose which one is the maximum point. The maximum point here that the decision maker can choose is we compare all of those alternatives, whether to build 50, build 100, or build 150 units. After we compare, then we get the maximum point here for the decision alternatives number 2, that build 100 unit of house. Then our decision is build 100 unit of house. Okay, so that's all about the constructing decision tree and how we calculate the expected value as the base of our decision. Thank you.